Hello guys, in this video I'm going to talk about troubleshooting when fine-tuning an LLM. Even if you're not programming, this is useful because if you're, using a no-code tool or if you're just talking to ChatGPT directly to kind of create a special output that you want and it's not working for either or, this will give you some insight on what's going on and what you can change to make it work for you without, coding or anything. But of course, if you are programming and you're trying to figure out what's causing the fine-tune errors, we're gonna go over that as well, and I'm gonna go through it raw. So you're gonna watch me struggle and watch my process and flow of how I figure out what's going on and going through the process, and I'm gonna explain everything that could cause issues with fine tuning in the LLM, um, and then also, but if you want to see the solution to me, why this wasn't working in the last video, just go to the end. The solution is right there. Okay. So yes, and then to refresh, fine tuning is pretty much trying to get a already made LLM, like one of the big ones like GPT, Cloud AI, whatever. Get one of the big fancy models and make it say exactly what you want it to say and specialize it, right? Like turn into a chef or turn into like a programmer, turn into a fitness guru, turn into a business developer, whatever it is you want. We're trying to figure that out. So right now, from the last project in the recent video I did, the LLM was having issues because I was fine tuning it. And just to refresh what's going on, I'm running the testing code and it's misclassifying some stuff. It's saying like apple is unhealthy and stuff like that, which is not true. Yeah, like see, it thinks grilled chicken's unhealthy and apples is unhealthy and quinoa, however you pronounce that fancy food name. I'm sure the let me not let me focus. But yeah, so yeah, and if I type in like grapes, it's probably gonna say unhealthy. Oh, actually said healthy. Okay, let me try apples. Unhealthy, which is yeah. So right now, so okay, so see, I just tested it, right? That tells me that the model is probably biased or doesn't have enough data, right? This tells you the model's kind of it's almost there. It's not just complete dummy. It's like okay, it kind of gets the concept of what healthy and unhealthy is, but it needs more information or it needs to study a little bit more. That's what this tells me right here. So its first step is to test your model. Test it a bunch. I ask it a bunch of questions, right? So matter of fact, I'm gonna jump ahead to me asking it a bunch of different like things to see what it outputs so I can get a better idea of what's actually going on. Seeing it mess up one time doesn't mean it's failing per se. I would say I ask it at least 10 to 20 times something and then look at that as a whole and figure out, oh, what's going on. Okay, so based on what I'm seeing, so I'll show you some of the outputs. So when you're troubleshooting a model, it's good to say the same thing twice or three times because that will show you the model just being random, right? Is it actually thinking or is it just saying random stuff? Like it has no idea what it's saying. It's just saying whatever it feels like saying, right? So I put grapes here the first time, it said healthy. Then towards the bottom, I put grapes again, it said unhealthy. That tells me that it's saying random stuff. And apple, and it said pot roast is healthy, sushi's unhealthy, and I think I put apple a couple times. Actually, I put pumpkin seeds twice. Pumpkin seeds, the first time was healthy, second time was unhealthy, right? So that just tells me the model is just saying random stuff. So it's not fine tuned properly. And yeah, so the first thing we need to fix is code. So when we're fixing models, the first thing is check for code error. In the last video, the code that I gave you guys, there are errors in there. So and I'm going to show you guys how to fix those errors and what those things mean exactly. So the when you run my last code, if you were to scroll up, as a matter of fact, I'll show you what happens in the original code. Let me put my code back to what it was before, so you can see before. Yeah, so I'm gonna bring my code back to its original state. Probably the same thing that you guys have if you're following this last video. But if you're not, if you're just watching, then yeah, just follow through. So pretty much, I'm returning my code to the original state it was before in the last video, where it was having a error that I didn't notice. Oh yeah, let me stop. Click this to stop. So I'm gonna rerun the model, right? Cool. There's an error that popped up in the last video, and I kind of ignored it or I didn't pay attention to it. The attention mask is not set right, and it's pretty much causing unexpected behavior, right? So that's the error. That error, I didn't even notice it before. That's like one of the most common errors is the attention mask, and this is because of the versions updating. A lot of the time, when the code updates or ChatGPT updates its code base or whatever, um, it will cause like formatting issues essentially, and a formatting issue It's kind of like car, like, imagine old cars how they didn't have like the reversing camera, and like a lot of new cars now have the reversing camera. The internal system of the cars are different now, right? Like you like to fix that old car, you actually need to fix the old car. You do a certain method, right? That method might not work to fix the new car. Okay, it's a new series. There's new technology inside of it. There's new ways that things are done, so it doesn't work exactly the same way. So I had some old code from like the previous way to set things up for fine tuning models. So I'll show you the old code. So the original in my original code, find this. If you want to find it, just Control F and then type inputs. Inputs. It should come to it. But if you're just watching, cool. So my code before is just this, right? But and then now the code what it should have been is this. Cool. So the difference between the two is that I still have input text, as you can matter of fact on both of them. Input text is still there. The shape of it doesn't matter. Don't think that because it looks different shape wise, like one's a line, one's a paragraph shape, it's different. No, it works the same way. Um, but anywho, input is just kind of, I don't want it to be super long over here. Yes, that's the same. Return tensors, that's the same. Padding is true. So pretty much I added three things. Padding is true, truncation is true, and return attention mask is true. What is padding, you say? Padding is essentially like this. So imagine I'm trying to write like it's like Word doc. So when I type a bunch of mumbo jumbo, right, and I hit enter, and then let's say I write a bunch of stuff over here, right, and it fits the screen. It fits, right? You see how like the Word document, it doesn't let me type past this. But if I go past it, it just goes to the next line. That's what padding is. Padding pretty much, oh no, that's not padding exactly, but we can get to a point. The point is that you see how these two both fit on this white sheet, and it is fine. And if I send it to you, you understand what's going on. The reason is because there's padding going on. All this white space here that you're seeing is padding. That's what it's doing. So before, my model was getting like pieces of paper. Like imagine, like pretty much imagine this was a text and this is a text. You see how like it doesn't line up, like one's shorter than the other. Or a better example is like this, right? This and this are two different lengths. Yeah, this is like, imagine this is a word or a sentence, and this is a word in a sentence. Like they're not the same length, right? So that causes a problem with the models. Is that each line you send the model needs to be the same length. And sure, let's say you only have two words mumbo jumbo. I even put the B in it. You add padding to give it that white space. Essentially, padding is giving it white space. You want to give the AI a sheet of paper, not a bunch of different, different lines and lengths of paper that ends up being like a frill, essentially, right? Um, so that's what padding does. It just makes it into one sheet that you give the model. So they're giving the model like one like a piece of paper with like a sentence, another piece of paper with a sentence. First is giving it an entire sheet of like normal text, and then it reads that. That's pretty much what padding is. Okay. Um, Truncation. So truncation is when you saw how I was doing this, and pretty much eventually it would go to the next line. That's truncation. Truncation is pretty much when the text gets cut short if it's too long. These models have a set amount of text they can take in at once, kind of like your brain. Imagine I said, memorize this sentence, right? And I'll be like, mumbo jumbo, humbo, combo, wumbo, 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 double, double, shoot, shoot. Like, you're not going to remember everything I just said because your brain has a limit of how much text it can take in and remember. And, like, remember, yeah, your brain has a limit of how much text it can take in and remember to say back quickly, right? So that's essentially what we're doing with the model. We're trying to give it enough words where it still remembers. So if I say mumbo jumbo, humbo, you can remember that quickly because most likely you can remember like 5 words max before you start not remembering the rest of the words, right? That's what we're doing with the model. So we're pretty much, if the sentence is too long, it will sort of chop off the ends of the sentence so it fits into the memory of the model. That's what truncation does. So pretty much it's creating a sheet of paper to give to the model for it to read like this instead of it having to read slips of paper at a time, which can mess it up, right? Um, no, I'm not saving mumbo jumbo. And then the attention mask. Attention mask is pretty much telling the model what to focus on. It's like, remember how this white space is pretty much, oh, do I ignore the white space or do I care about the white space, right? When I didn't have it before, it would consider the white space as something important, like it needed to know. Like, oh, mumbo jumbo, all that space, yeah, I'm kind of confused. Like, why is all this space so important? So it will include that into its calculation of, its answer or whatever to you, right? Um, and all that stuff. And something like the word the, a, and it will ignore these words, but only if it has an attention mask. So attention mask tells the model what words are important and what words are not important, or what is not important in it. Like white space, periods are kind of unimportant. Commas are kind of important, right? Um, Things like that. Capitalization, is a capital T more important than a lowercase t? Depends on the context, right? So it gives the model an idea of what's important to talk about. So that's added in. So before, I was giving the model a very unorganized, raw data essentially, but now we cleaned it up. That's what this does, right? Now, so this is the before. This is what it was before, right? I was missing two things. Let me show you both. So I'm gonna bring this back. So yes, so that's how that worked. Did I close the other one? Let me shut this down because it's gonna be wrong. Okay, cool. Now, so this is the before, what I had in the last video, and this is what it is now. The main difference is the input. The input is different, and then I added the attention mask. Everything else is the same, right? I added this attention mask line, and then this ended up changing. So this pretty much became this, and then I added this line. So once again, it's the attention mask. You have to apply it to the input and output. That's all it is. Pretty much the attention mask needs to be in the input and the output, right? Cause this is the output and this is the inputs. So both need the attention mask, and then so that way it knows what to pay attention to in both the input and the outputs, right? And then what this is just a formatting thing. So this is just pretty much giving. So remember the AI models, they understand numbers. They don't actually speak English. We have tokenizers that translate our English text into numbers for the AI to understand, right? We're speaking the AI language using tokenizers. It's our direct translator, all right? The tokenizer is a person that's there translating for us, but in text form, right? This inputs thing pretty much gives the model the language it is used to, which is the numbers, right? Versus giving it text. It struggles with text versus numbers, so that's pretty much what this does. It just gives and the idea is that a word is like a number to it. Like the word A might be the number 1, and the word apple might be number 54. It's kind of like how the model works, okay? So when you see a bunch of numbers and stuff like that, and like something called a logit, that's what that means. It's just the numbers represent certain words. Like the number 57 might be pineapple, right? And stuff like that. So that's pretty much giving it the list of numbers that represent words for it to understand. And then the attention mask will make it focus on which ones it needs to focus on, right? White space is usually 0. Like kind of the attention mask usually ignore number zeros and stuff like that because that usually means white space. But yeah, that's pretty much the only things that I changed. Everything else, I'm gonna dive deeper into a different video. What these other things mean, like temperature just means how much randomness the model is gonna use when it talks, or how focused it's gonna be when it talks. But like I said, we'll get into this other stuff. EOS. We're gonna get into this in a different video. I'm just showing you what I changed. To fix the attention masking issue, right? But as you can see, even though I changed that issue, I'm gonna stop running this. So now when I run it, it's gonna work now. And then in the new video, like in this video, in the description below, there's a link to the new updated code file. So you can just start running and using this code file without worrying about changing stuff yourself. If you're nervous to change code, or if you're just learning, you can just continue watching. So yeah, as you can see, it's still not working properly. Because I have a pretest in here and it's not working properly, even with the attention mask. So the next thing you look at is model path. Is the model path correct? Model path is just like the location of the model on your computer. Does the code have the right path, right? And let's say you're using a no-code tool, is that path, are you using the right model is what you need to kind of worry about. You might be using the wrong model. So we're going to go make sure that our model is the correct one being used. Where's the path? Here it is, the path. So I already kind of changed mine, but it's just model path variable. You can do Control F, find model path. The way you find it is if you're in PyCharm, which I recommend, right click, open Explorer. It should pop up. I would hold Shift, right click, and click copy path. Put R in front of the quotations, and then Control V, paste it, and then remove these extra like quotations. cool. And that should be the correct model path. If you're in like Google Colab, I showed that in a different video how to do that, but it's pretty much the same idea. Google Colab has like a drop down for that. So, but I already had that before, so that wasn't working. So I know it's not the path. So double check the path and make sure your path is correct. Cool. Or make sure that you're using the correct model. Like check the model names, everything, the weights and all that biases and stuff. Cool. Next is imbalanced data, right? What does that mean? So we're gonna go to our Google sheet from before. 16-minute mark. Okay, cool. So I opened up my data, right? So to know if your data is balanced or imbalanced, I'm gonna do the simple way. There's like better, more efficient ways to do it, but just to teach you the concept of unbalanced and balanced data. So we need to check how many healthies we have versus unhealthies, right? So one way to do that is I'm gonna kind of click on this. I need to filter it. This is not Excel, so format. There it is. Create a filter. Cool. Click down and let's see how many healthy we have. So the amount of healthy we have is at the bottom right, 31 out of 62. So if we do the math, half of 62 half of 62, 31, right? So this is 31 out of 62. And I'm using the calculator. Yes, I know how to divide. It's just some people, like I'm showing you my exact process. Let's say the number was 258, I'm still going to use the calculator no matter what, just to double check. So, yeah. And the other half is, I'm assuming, unhealthy. So let's put that, oh wait, it's pretty sure it is a hit okay. Unhealthy is 31 out of 62. So the amount is, it is balanced. So if it was unbalanced, essentially what that means is that there'd be more unhealthy rows than healthy rows, right? So it will lean towards saying unhealthy because it's more unhealthy rows. So if I made it unbalanced on purpose, this will show you what unbalanced would look like because my thing is balanced. I want to make it unbalanced now to show you guys. If I made it unbalanced, cool. Is it bugging out? What's going on? 2 to 13. Oh, I deleted it twice. My bad. Okay, cool. Okay, I did delete. I just didn't see it. Okay, cool. All right. So yeah, I did delete it. Cool. So now, now this is unbalanced. If I right click this, create filter. If I check, oh, it's only unhealthy. Well, yeah, this is super unbalanced now. It's straight up just unhealthy. And so the 0% of it's healthy, 100% of it's unhealthy. That's super imbalanced. But let's say I made it, never mind. I messed up. I grabbed it while it was filtered. That's my bad. Let me grab it now. So unfilter it before you copy and paste it over. Well, actually, don't copy paste anything. I'm showing you imbalanced. Cool. So yeah, let's say I deleted these 3 rows right here. That's not 3 rows, but yes. So now if I do this, create filter, healthy, 23 out of 54. 54 divided by 2 is 27. So this bad boy, yeah. So it's imbalanced because well, granted, because one is only 2 options, which is healthy and unhealthy, and half of that should be 27. If it's 23, it's imbalanced. So that means there's more. So there's 23 rows of healthy, and then unhealthy is 31, which is more. So being that there's more unhealthy rows than healthy, it's unbalanced. So this will cause a problem in your data set. So double check your data set if you have imbalanced data. Now, the way you figure out like these numbers I'm doing, let's say you have 1,000 rows of data, right? And you have 3 different possible outputs. Then when you divide it, it should be as close to like the 333 as possible. If you have a data set that's like, but it's not too crazy where it's like, oh, 334, like one of them is 334 rows, 1 333, 1 332. That's not a big deal. Like 1 row difference is gonna make the model act stupid. It's when it's like huge numbers, like let's say like 60% of the data is one and 40% is the other, that's more of a problem, right? You want it to be as balanced as 50-50 as possible. If it's two, if it's three, obviously like 33%, right? And let's say I have, but here's the thing, that now when you have multiple different kind of text outputs, right? So if you have 1,000 rows, and then you have like 20 different possible outputs of something the model can say, that means your data needs to be like at least 50 examples for each of those outputs. It needs to be equal across the board. If any of them are too high or too little, then the model might start being biased, saying one even though it's wrong. Essentially, is what I'm trying to say. But yeah, but our data is actually not imbalanced, so that's not the problem, right? I actually should add this here. More data. Yes. So the next thing we got to check now is, do we have enough data? Because these LLMs have been trained on billions of rows of data, right? And if you give it a little slice of pie like this, let me delete this real quick so I don't confuse myself. This might not be enough data, right? So I'm actually gonna add some more data manually, and I'll come back in a second. I'll jump ahead. Actually, no, I'm gonna show y'all me making the data. I'm gonna actually use ChatGPT to get it done faster. I asked it to give me a list of healthy foods. Cool. And now I'm gonna prompt it again to be like, oh, give me these foods. Oh wow, it's giving me a long list of healthy foods. I'm gonna stop it right now. Give me a list of 50 healthy foods that I can copy and paste into Google Sheets. Right? So it's gonna produce that for me. And I just hit copy. I go here, I go to the bottom. Make sure my filter's not on. Okay, yeah, nothing's being filtered. I will go here, hit Control V, and it will add that list. I just grab this bad boy and I double click this. I just double click that corner right here and it brings everything healthy down. So all these are healthy now, right? Cool. So I did 50. So now give me like 50 unhealthy. Give me 50 unhealthy now. Pancakes with syrup. Microwave popcorn. It's funny. Nachos with cheese, queso dip. And it's okay that some of the things repeat. It's fine if some of it repeats. Like if some of the foods are said again, that is okay. I'm just gonna copy this, place it here, Control V, double tap. Cool. Unhealthy. Cool. All right, so I added more data now. So pretty much I doubled the amount of data. So now we have 195 rows of data. Yeah, because 195 rows of data. That. Wait a second. Why is it? That's an odd number. 1 second. $113. Just making sure. 82. Unhealthy is imbalanced right now because I deleted data from earlier. Okay, cool. So now I just need what's so I need to make it balance. I need let's see, 195 divided by 2, 195 divided by 2, because there's two outputs, 97. Other one's 113. So let me do 113 minus 82. I need 31 more rows. The reason I'm doing that is because I want to match healthy. So if healthy has 113 rows, I just did 113 because of 70 rows that healthy has, minus 82, which is what unhealthy has. I'm just missing 31 rows. So give me 31 more. Sweet tea is unhealthy. Shocker. Fruit punch is unhealthy. I am not surprised. Frozen pizzas, cheese puffs. That's so funny. Buffalo wings with ranch is unhealthy. I disagree, but we can argue later. Cool. Did I unfilter it first? Let me make sure I unfilter it so I don't get confused when I add stuff. There we go. Cool. Yeah, this should balance out the data now. So now if I do healthy, should be 113 rows. I'm looking at this right here. Now if I do unhealthy, 113 rows, cool. My data says balanced, which is good. Cool, so now this is balanced out. So let's try now adding this with more data. So I'm gonna train it now with more data. Let me download this as a CSV. Healthy food data sheet 2. I'm gonna click this to open it. Where you at? Okay, I'm gonna put down the side for now. Let me go back to my Python code. I wanna switch out. I'm gonna right click, open, explore. I'm gonna add that into it. So I'm gonna I'm gonna copy this, close this now, Control V to paste it. I pretty much pasted it into this. So now it should appear. And I'm gonna right click. You know, I shouldn't have closed it that quick. Sorry. Explorer, my bad. Hold shift, right click, copy path. Yeah. Now I close it. Cool. And I'm gonna go to the training code, which is the fine-tune practice.py code, and you find that file path for training the model. Pretty sure if I look up sheet 1, there it is. Yeah, I'm gonna place this inside instead. Take away the extra quotation marks. Cool. So now the model is gonna train using this instead. So we're gonna try running this now and see if it understands better. I'm gonna right click, run. And also, another thing you gotta check. Make sure it makes sense, because sometimes you'll have like actually confusing stuff in here. It's not gonna make any sense. Like there's no actual, like it's breaking the pattern, right? So you need to actually double check if these are actually healthy. Now, if you have a lot of data, it might be hard to double check these things on your own by yourself, but it might have to come to that where you need to check like each row, like, okay, is this actually healthy or is it actually unhealthy, right? Like kind of when I questioned the buffalo wings with ranch, I questioned that one. But most of these foods, air pop, zucchini, what is plain kefir? Chia pudding, I would never eat that. Oh man. Chips, soda, candy bars, donuts, ice cream, white bread. White bread is so funny. Sugary cereals, pizza with extra cheese. Okay, so pizza is not healthy. Is pizza up here as healthy? Interesting. Specifically, just extra cheese. It just kills you now. Okay. Nachos with cheese. What? I'm gonna just let it slide. Milkshakes. Oh, probably the sugar intake, like instead of deep fried cheeseburgers. Packaged pastry sausage. Some of these foods are the same. Are they healthy? Yeah, a lot of them are the same. I'm following. Kiwi, barley, buckwheat. What the heck is buckwheat? Who eats buckwheat? If you eat buckwheat, you need to let me know what that is. Buckwheat. I'm gonna say that now. Olive oil is healthy. Avocado oil is healthy. Flax seeds. Okay, I guess these are healthy. French fries, fried chicken, bread, cake. All right. A lot of these are kind of repeated, but not everything's repeated. Churros, not the churros. Leave my churros alone. All right, cool. So I looked at it for a little bit. It's like it gets my green light. So I'm gonna run this code now. The fine-tune practice code. I'm gonna run it and let it train now. I will hop back once it's done training. All right, so it's done training now. I got my little output. So accuracy is 84%. Remember in the other video, the accuracy was 60%, and I still went along and was messing with it. Now it's 84% accuracy, right? So which gives me a good sign. So, and the thing is, like, when you're fine-tuning models and you get an accuracy score under 80, it's probably not going to do exactly what you want. It kind of matches. Like, if it's like, it's almost 50-50, going to say whatever it wants. So anywho, let's just run this test code now, the testing the model PY code, and let's see what happens, if that fixed the problem. Okay, so just from the test output, grilled chicken is supposed to be healthy, but apple came out healthy. So when you see stuff like this, right, grilled chicken is unhealthy. We need to figure out why is that unhealthy. Is it a bad guess, or is it the data? So now let's check the data from before, right? The data from before. Let me type in for what was it? Grilled chicken. Grilled chicken. Grilled chicken. Control F. So grilled chicken is not in the healthy. So the model was never trained on grilled chicken. And this goes to show you guys, if you don't teach the model the information, it's not gonna get the idea. Grilled chicken was never exposed to it as a thing. Now maybe if I said sauteed chicken, it might have actually known grilled chicken might be okay too, right? But you gotta keep in mind this model is only so many few rows of data, right? It's only like 100. How many rows is this? 100 a couple of rows of data, and these models are trained on billions of rows. So you guys gotta keep in mind that's actually really big. So I'm curious now if but Apple, because Apple is in the data. So let me try it now. Let me try Apple. Let's see what it says about them. Apple's unhealthy. That came out incorrect. Let's try grapes. Let's try apple again. Let's see if it is just being random, or if it truly thinks it's unhealthy. Apple, unhealthy. Let's try grape. Healthy. Let's try grape again. Healthy. Let's try grape one more time. Unhealthy. 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 Yeah, it's being random again. Okay. It's still random. Okay. Let me try a different food. Let's try fried cheese. Unhealthy. Let's try cheese. Unhealthy. Let's try fried cheese again. Unhealthy. Let's try soda. Soda. It probably knows soda's unhealthy. Okay. So now, so now that we see that it's still not doing what we want, let's try. Let me try apple pie. Pie, unhealthy. Cool. So I'm gonna stop it now. So now it's still being kind of random. So what I'm gonna do instead now is let's go back to the data, and here's exactly what I'm gonna do. I'm gonna change one of these to grilled chicken. And then is literally what I'm gonna do. I'm gonna highlight this, Control Shift down, Control C, click here, Control V. I'm gonna double this up. I'm gonna double the current data that since it's so only because it's so small. If you have a billion rows of data, you have a different problem on your hands. But because the data set is so small, I'm gonna make it a little bit bigger. And then the next thing you guys think about too, if it's struggling this hard, that means there's not enough strong patterns for this model to understand what's going on. It's not, it doesn't understand why frozen is better than why frozen food is better than the fried stuff, right? Or why pudding cups, because pudding cups right here is unhealthy, right? But then I think we had like chia pudding earlier, and that was considered healthy. So it doesn't know why one pudding is better than the other pudding. So it's not really understanding what's going on unless you give it more context. But right now, like I said, I'm showing you all the things you would do. Let's say you have enough context, whatever. Let's just rule out that it's the data, right? I'm showing you all the methods that could possibly be the problem. Pretty sure I put that. More data. Yeah, more data. Also could be too much data as well, but usually it's a more data problem. So let's save this now. I'm gonna download this, and then if this doesn't work, I know what to do next. But we're gonna go through all the troubleshooting stuff. So we got 3. I'm gonna open this. Let's put that in there. Okay, so I'm gonna do my usual process as before. I'm gonna add the sheet in here. I'm gonna train it again, and then let's see. Wow, you guys are really getting some like you're in the world of an AI engineer for sure. Open Explorer. Yeah, make sure it opens. Sorry, I have 2 windows open, so like you're not gonna see some stuff on the other screen. Copy, paste. Cool. That's here. Remember shift right click, copy as path, exit, and I'm gonna change you to being I'm gonna hide the whole thing this time. There we go. That's way easier transition. Cool. Now I'm gonna train the model once again, and then we'll see how this works. Okay, and we're back. All right, I finished training, and the accuracy score is 97 now. See, we have a better accuracy score. So let's see what's going on. All right, so we're gonna test this again using the testing the model PY. And just so y'all know, this is exactly what OpenAI and all these big AI companies go through on a daily basis, if not a monthly basis. This process of trial error is how AI works. We don't just make a formula, train it one time and we're done. Most likely, most models that you're given, the fancy ones, have been trained thousands of times just to get to this point. We're trying to figure out how to make these things understand. It's trial and error. AI training, AI engineering, just working with AI itself is a trial and error. Even ChatGPT, you'll see sometimes that it says something wrong, right? People need to understand these things are not just, they're not always right. And when you're working with training them, you need to understand that they're going to be wrong sometimes. And part of that reason is your fault for not training it properly, or the model just can't handle what you're trying to teach it, or maybe the solution you have is too complicated for AI, or maybe the solution you have is not an AI solution. Maybe it's a solution that can be solved with code, or you still need to have people. This is why I tell people AI is not going to take anyone's job. We're not at the point where AI is always right. We're not at that point yet. We're at the point where AI is just as right as regular humans. Okay, cool. So I ran the test code, testing the model, just from the pre-test. Quinoa, however you say that word, is healthy. I it's that weird rice thing, and apple is healthy. Grilled chicken is still unhealthy. So let me test this now. I'm gonna try and see something that it got right before apple. Let's try apple. It's healthy, which is correct. Let's try apple again. It's still healthy. One more time. Unhealthy, right? So that's incorrect. Okay. Let's try apple one more time. Back to healthy. This tells me the model is gonna say, most likely it's gonna say apple is healthy, but there's a chance it's gonna say unhealthy still. A small chance, right? Let me try it again. Healthy. You see that? Out of how many? And do some quick math real quick. I'm gonna teach y'all, not teach y'all math, but like, wow, I got a timer out here. Yeah, I'm gonna time calculate this stuff. Let's do a calculation real quick. So how many times we did this? 1, 2, 3, 4, 5, 6, 7 times. So it was right 6 out divided by 7. It was right 6 out of 7 times. That's an 85% accuracy. That's really high. That's a big 85% is really high. But look how that small percentage of error is such a big impact though. You don't trust his AI now because he messed up one time, right? These things have to be really, really, really powerful for y'all to trust them. And most of the times, ChatGPT is wrong like this. It might have an 85-90% accuracy rate, but you'll trust everything it says. You got to be careful when you trust these models' outputs and always double check the outputs, right? Another way around this, there's a technique around this as well, like ensemble or voting system. But we're not going to do that in this video because then that gets kind of complex. We're not trying to get complex. We're trying to keep it simple, right? Because the solution to this was to have it vote. Like imagine you had 7 AIs, you show it the same thing, all 7 of them the same thing, and they all have the different outputs. You just vote who was you vote the most. Like if healthy was said 7 times and one time was wrong, obviously healthy is what you're gonna say, right? It's kind of like the process of that. Essentially, it's like a voting system. Like it votes. I think it's healthy. I think it's unhealthy, and then whoever has the most votes gets that's what it says, right? Instead of just one model saying something, because kind of like asking one person for advice versus asking 5 people for advice. You probably get better advice asking 5 different people than asking one person, right? That's kind of like the concept I'm trying to explain. That will solve the issue, but we're not going to code that in this situation. Most of my advanced models, most of my advanced systems use that. Hence why I'm able to get the outputs that I want out of AI, and beginners usually don't, or people that aren't adverse in the space struggle to get AI to do what they want because they don't know these concepts. But teaching it now, yeah. But anyway, let's try something else. Let's try fried cheese. Unhealthy. Fried cheese. Unhealthy. Fried cheese. Fried cheese, and let's try it again. Fried cheese. Cool. I'm just gonna say right there, it did a pretty, yeah, it knows fried cheese is not good. Fried cheese. I think it knows the word fried um, is unhealthy automatically. So that works fine. So certain try grapes. Unhealthy grapes. Unhealthy, yeah. For some reason with fruits, it's just not getting the fruits. Let's try yeah. Cool. So it had one unhealthy for fruits, but then it's healthy for. See, I even spelled grapes wrong. See how I spelled GRAAPES? It still knew it's healthy. It gets the idea. So that shows a lot of intelligence. Now, grapes, it still had one wrong. Let me try one more thing. Soda. I think because some unhealthy foods, you know what it is? Some unhealthy foods, and this is where you have to think about the process too. Use your brain. Um, why would it confuse grapes and apples as being unhealthy? Because apple pie is considered unhealthy. Apple candy is unhealthy, right? So the word apple, it might start thinking it's unhealthy now, or it doesn't know if it's healthy because you know other foods that have the word apple in it are considered unhealthy, right? But then apple pudding, or not apple pudding, applesauce is considered healthy, right? So now it's like now you have to like you're confusing it now, which actually makes sense with the situation, right? So this is where a human would dominate the situation, but we can give the AI more context. So I'm gonna stop right here, right? So you guys already saw that when I changed the data, like when I give it more rows, it did better. So this is why a lot of time you see giving the model more data, it makes it work better. But we're gonna hit a wall. So now that we hit a wall right now, now what this tells me is that I need to add more context to the foods, right? Exactly what's going on with the foods. So to add more context to the foods, I'm going to add the context just in here, so that way I don't confuse you guys. But let me use jump ahead for that. Actually, no. Let me show you exactly how to do this quick, because I want to teach you guys everything. Like, so I'm gonna upload the what's it called? The Excel sheet or the CSV, the GPT. I could use Claude too, but I'm using this one because everyone's more familiar with this. I prefer Claude. And I'm gonna ask it to add more context to the input row for each food. And now I'm gonna tell it like an example. Example, what's the first one? Baked chicken. Baked chicken. Context would be made in the oven. Made in the oven. How much protein does it have? Flip. X amount of protein. Because what makes food unhealthy and unhealthy, you need to make the AI understand that. Because just seeing names, it's just guessing. Oh, is this unhealthy? Like it doesn't know. It's just seeing random names and trying to figure out a pattern amongst the names. But if you give it context, what makes something healthy or unhealthy? It's not the name. It's how much sugar is in it, how much fat is in it, how much protein is in it. Now, if you teach the AI this, like tell it the food name and then show it how much protein is in it and fat and sugar, then it can figure out a pattern. Oh, baked chicken tends to have low sugar. That means it's healthy, right? Cite stuff like that. Give it more context to learn from. Just giving it words isn't going to teach it what's going on. So that's what's going on in this situation right here. So made in the oven, amount of chicken, amount X amount of sugar, and then we do carbs. X amount of carbs, X amount of sugar, X amount of fiber, X amount of vitamins and minerals. Cool. So this right here, right, is the kind of context I need each food to have, so that the AI can understand like what is actually going on. So I gave it the data and I gave it the prompt that I have, and now it should be producing this. So I'm gonna jump ahead for you guys because this video is getting a little bit too long. Not too long. It's getting a little long, but I just want to make sure I don't overload you guys. So it produced output like this, which is not what I want. It's actually not a lot of them. It's saying like preparation varies, nutrition varies. all this jazz. So I'm specifying again. Just pick a value for macros and micros for about 1 pound of the food or one common serving size, and just pick a random cooking method for it that's common. So I'm gonna add that into it to get what I want. All right, the output now is exactly what I want, except that there's 2 rows of it, but I can fix that myself. I'm not gonna go back and forth with this thing. As a matter of fact, I'm gonna open that now. File, open, upload. I'm gonna upload that new file I just downloaded. This one. So I'm gonna upload it. Cool. And what I want is I'm just gonna copy this whole row, copy it. I'm gonna cut it. Come here and then paste it. And then change the name to just input, because the column name needs to stay the same. Input. Cool. And boom. Now I have the data that I want. And now I'm gonna Control S. I'm gonna save this. Oh, I'll just click this to save it. Download CSV. Downloaded CSV.csv. That's crazy. What is his name? Hold on. Download. 1 second. Make sure it downloads properly. CSV.csv. Why is the name CSV in the name? Updated food data. Updated food data. File. Download. I'm just gonna have to. 1142. Okay. This is my data set right now. 620, 1142. Okay, yeah, this is the one. I don't know why it looks weird on the download tab, but it's okay. Cool. So now I'm gonna upload this to the model. I'm gonna jump ahead. Cool. I loaded in that new file with this weird long name. Interesting. And then I'm gonna train it now. Alright, we're back. So I trained the model on the new data with the context, and grilled chicken healthy, true. Quinoa healthy, true. Apple healthy, true. The other one's French fries and chocolate cake unhealthy. Cool. So let's try this. Apple healthy. All right, let's do it again. Apple healthy. That's 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. 100% accuracy now with the word apple. Let's try fried cheese. Fried cheese. Unhealthy. Again, fried cheese. All right, let's try grapes. Let's try grapes with 2 A's. They spell it wrong. Grapes. Still healthy. Cool. So right now, I'm going to tell you right now, I already know it's working. And this is the thing I want to teach you guys, right? So now it's working. And fun fact, I actually checked my training code earlier. There's actually, remember the attention mask issue? I have that in here too. I didn't update the fine tuning training code to have the proper masking. But even regardless of that fact, the data was the main problem essentially, right? Because the AI can still work without the masking. It just has a higher chance of messing up now. But hey, we got past that with context and the proper data, right? Cool. So the idea that I'm trying to show you guys is that sure, AI is going to take your job, whatever. No, that's not true. You still need to be somewhat of a specialist or know the knowledge of the thing you're training the model on. If you're trying to train this model on what's healthy and unhealthy, you need to have food science. You need to know food science. Luckily, I know food science. I used to be a trainer for like 5 years back when I was younger. I was a trainer. I was super into fitness. I was I was super into the fitness and workout space. Obviously, because I'm a dancer, so my body has to stay healthy, and I care about my health and all that kind of jazz. So, yeah, the point I'm making is I have this knowledge of fitness and health, so that's why I knew. Oh, probably it doesn't know like what's healthy and unhealthy because it doesn't know the macros in it and the micros, right? But when I was talking to ChatGPT, right? When I was talking to it, I was using certain jargon like macros, micros, and stuff like that. Or cook it a certain way, or I say like, oh, a pound of substance or a serving size. This jargon that I'm using is only because I know this only because I'm in the space, right? If you're not in the space of something, you're gonna have to learn, and you can use AI to teach you food science. You can ask it, oh, why is this probably not working? It'll probably will tell you potentially, but the more you know about the subject, the better you can train it on the subject yourself. How are you gonna teach someone something that you don't know yourself, right? If you're gonna fine tune a model, you're teaching that model something. If you don't know it, how are you gonna teach it to someone else? Right? So that's the concept people kind of don't understand is that they want to teach these things stuff that they don't understand. So when it performs incorrectly, they just the code's wrong or the model's dumb or oh my gosh, like this is too complicated and hard. No, you're just not adept. You're not the right person to be tuning this model, and this is why you always need this is the whole thing of the AI job takeover. It only knows what you teach it, and if you teach it wrong, it is what it is. People forget these things do act like human brains, but they're not human brains at the same time. Okay. Now, let's say I'm still going to talk about the other two ways that you have a problem and to fix it. The epoch could be too low. Epoch's essentially how many times it goes into a study session, right? When you study, do you study for 1 hour and go take the quiz that costs you $1,000 or the exam that costs you $1,000, or do you study for like a week or 5 months and then take this super expensive exam, right? It's kind of like that. It's like you're giving it more time to learn. That's what epoch is. Epoch is how much time you're giving it to learn the subject matter. If it's too low, it might if you have a lot of data in low epoch, it's probably not going to be enough for it to learn. If you give it too much data, if you give it very little data and a bunch of epoch, doesn't make it super good as well. It might memorize everything, which is not what you want. All right, you're gonna have to find a balance between epoch and the amount of data, right? For now, I know my epoch is the right amount, but I'm gonna show you how to change that in case you want to change it. So you type in epoch, and this is for the training code. Go to your training code. Exit out of here. Go to the training code, the fine tuning code. Control F. Type in epoch, and it's right here. It's at 5. So 5 epoch. That means that's 5 study sessions essentially. So you can increase this number to like 10. But if you're fine tuning a model, you probably want to avoid fine tuning past like 15, right? Unless it's like a really huge model, which is just not. From like 2 to like 15 is a good number. Like 2 could be enough, or 15, but just keep in mind that's like the good range. I had 5 before, so but you could fine tune on more epoch. It just depends on you. Like once you get more advanced, you can maybe do 30, 40 if you do want it to memorize stuff, whatever. So that's how you change the epoch for this particular code that I have. And if you don't, if it's in the training arguments, right? And then the last thing you need to look at if your model is not performing well is learning rate. Is the learning rate, which is this guy right here, learning rate, and which is in the training arguments variable, is it too high, too low? Now, if I were to change this, I would probably change it to a 1. 1 to 5 is a good range. It's also like, this gets kind of complicated to explain, I'm not going to lie. But I would say learning rate's the last thing you need to worry about when it comes to training models. No, I would say if you're having issues, start with this and increase it from there up to 5. And that's still not working, then you need to do some research on the learning rate, or there's another deeper issue that's going on. And there's also batch. I forgot batch size as well. Probably batch is what you checked before. Batch size. Learning rate is just like how fast you're making it learn. Essentially, like are you speed running it or are you taking your time in learning? Right. That's just learning rate on an easy to understand basis. And then something like batch size is also another thing. Batch size is like how many words are you trying to teach it at once, right? Are you teaching it like let's say you're trying to teach them how to speak Korean? Are you showing it 50 words to learn from Korean at once, or just 2 words, right? You probably will learn more effectively if you learn 2 words at once than 50 words. That's batch size. So pretty much, it's like I show it 4 foods at a time and try to see if it's healthy or unhealthy, right? Because you can't learn too much at once. Is what the concept is. So this is kind of where like you have to figure out a nice balance. It is kind of guessing. I'm not gonna lie. The more data you have, the more batches you need. The less data you have, the less batches you need. So 4 is fine for me because I only have like, how much rows of data do I have? I only have like, I think it was 200 rows of data. So like four batch size of 4 makes sense for 200 data. If I have 2,000 rows of data, might need 20 as my batch size, right? So it really depends on your data, and also it's just a lot of trial and error. That's why I went through the easy ones first. But essentially, that's troubleshooting, fine tuning a model. Okay. Hopefully that gives you a lot of insight on what goes on behind the scenes and making the model work properly when you're fine tuning it, and what can go wrong, and what the actual issue is. So if you're using a no code tool, at least you'll be able to now troubleshoot a lot more effectively, right? Yeah, so that's pretty much it for this video. If you want to learn AI one-on-one with me, I teach AI one-on-one in groups to departments. I code AI, I can integrate it, I can fine tune models, as you can see, all that jazz. So if you want to work with someone like me and get some pretty cool stuff being made, or you want to fix a problem that you're having right now, you want some advice about AI, or you just want to learn about the space, learn how to manage a team of AI users, or learn how to use it for your company to make more money, all the jazz, hit me up. My email is in the description below. Don't be afraid to reach out. Yeah, I appreciate you guys very much for tuning in. Yeah, that's pretty much it. Peace.